We're on number 8, right? Example 8. Okay, so it says using Venn diagrams to solve word problems. If you remember, Venn diagrams are where we draw pictures of our sets. You got your quiz? We draw pictures of our sets. And so we're given a word problem. The best way to solve these is to draw a picture. It says the choir has 24 members. 10 of the members sing, 12 of the members play the piano, and 6 sing and play the piano. So we're talking about 2 sets happening here. People who sing, people who play the piano. Don't want to do that. Who is the universe? Who is inside the rectangle? Right, the 24 members of the choir. That's the whole choir is in here. And then inside this choir rectangle, we have 2 sets we're talking about. People who sing and people who play the piano. So I'm drawing my generic 2-circle Venn diagram there. And it says there's 24 members total in the choir. So this whole rectangle, how many different little parts or compartments is this Venn diagram broken into? 4. That's very important. There's 4 parts. 1, 2, 3, 4. Okay? There's 4 different spaces. If you add up all 4 of those spaces, it's going to add up to 24. So this whole thing is going to add up to be 24. What we know right now, it says 10 of the members sing. That means this entire circle for sing is going to add up to be 10. We don't know how to split that number yet. Okay, we don't want to just put a 10 there because there could be people in here. And so it says 12 of the members play the piano. So the whole piano circle adds up to 12. This is the first number we could put in. 6 sing and play the piano. So we can put 6 people right there. Working our way out, if 12 people play the piano and I already have 6 in the piano circle, how many's in the other part of the piano circle? 6. And if 10 sing and I already have 6 in the sing circle, how many is in the other part? 4. I have 24 total in the choir. Who are the people outside the circles but inside the rectangle? People in the choir who don't sing or play the piano. So we're kind of wondering why they're in the choir, but they're there. How do we find how many people are there? Subtract it, right? 24 minus 4 minus 6 minus 6. And we get, help me here, 8. It's early morning. So once we have our picture, once we have all 4 parts put into our picture, then we can answer our questions. How many of the members only sing? 4. How many of the members cannot sing or play the piano? 8. All right. All right, number 9. It says if the number in the universe is 230, so I'm going to stop right there. I'm going to draw my universe. Everything inside this rectangle is going to add up to be 230. Okay. It says the number in A is 110, the number in B is 95, and it goes on to tell us other things. So I know I have 2 sets. So I'm going to go ahead and draw my 2 sets overlapping slightly. This is set A, set B. How many different little compartments are there in this 2-circle Venn diagram? 4. So those 4. So those 4 parts are going to add up to be 230. The number in circle A, those 2 parts are going to add up to be 110. The 2 parts in circle B will add up to be 95. But the number in A intersect B, that means A and B, is 40. So I can go ahead and put that number in. I know right where it goes. Backing up, if the number in B is 95 and I already have 40 in that circle, how many's in the other part? Not everyone at once. I can't hear y'all yelling at me. 55, thank you. And then if the number in A is 110 and I already have 40 in there, how many's in the other part? 70. You are allowed to use calculators in this class. Okay, and then I have 230 total. How do I find out if anyone's outside the circles? Add them up, subtract from 230. And what do you get? 65. So then the big question is, find the number of elements in A union C complement. Well, that's all fine and dandy, but if you don't understand what that's saying, you can't answer the question. So A union B means everything in A plus everything in B. Complement means it's not in. You can say A or B, you can say A plus B. So where is it? It's the 65 right there. Technically, all of these numbers are in the universe, but that one's in the universe outside the circles. Okay, number 10, the results of a survey of 85 visitors at the Grand Canyon showed that 25 speak Spanish, 14 speak French, and 4 speak both. So I'm going to draw my universe. I know my entire universe adds up to what? 85. I've got 2 circles going on here. One of them is representing what? Spanish. The other is representing French. I have 4 different little compartments inside that Venn diagram. I'm going to start right here where it says 4 speak both Spanish and French. 4. Then backing up, it says 14 speak French. I already have 4 in the French circle, so that leaves 10. Who are those 10 people? What do they do? They only speak French. They don't speak Spanish. Okay. 25 people speak Spanish. So I already have 4 in the Spanish circle. That means 21 speak only Spanish, not French. And then, who are the people outside the circles? People surveyed at the Grand Canyon, I don't know why they're doing this survey at the Grand Canyon, but people surveyed at the Grand Canyon that don't speak Spanish or French. So if we add up all the numbers in the circles and subtract them from 85, what do we get? I got 2 different answers here. 50, 51, 65. Y'all gotta make me look at my notes. 50. Okay. So now we can answer our question. So all of that's just prep work. Now we will answer our questions. It says, how many speak only French? Those 10 right there. How many don't speak Spanish or French? 50. So hopefully you'll agree, answering the questions is actually really easy if you got your picture drawn. All right, one more of these. It says the results of a survey of customers at McDonald's restaurants showed that 28 purchased either a hamburger or French fries. What does that mean in mathematics? Plus, if I said, hey, I went to McDonald's and I got a hamburger or French fries, what'd I get? I mean, I could have gotten just a hamburger, right? I could have gotten just French fries, but I could have gotten both hamburgers and French fries. All of those are included in a hamburger or French fries. One or the other or both. All right. So I'm going to do my universe. I got my hamburger circle, my French fry circle. It says 28 purchased either a hamburger or French fries, and we know that means or both. So all 3 parts inside the circles are going to add up to be 28. It says 20 purchased French fries. So there's 2 spots in the French fry circle. That'll add up to be 20. 17 purchased both a hamburger and a French fry. That one we can put in right there. Then backing up, if 20 purchased French fries, how many purchased only French fries? 3. And it says 28 purchased either a hamburger or French fries, which means or both. So how do we find this one? 28 minus 17 minus 3. And so we get 8 people who purchased only a hamburger. All right, so we were doing 2 circle Venn diagrams. I'm going to introduce you to 3 circle Venn diagrams. Don't freak out. We're not going to go higher than this. But in a three-circle Venn diagrams, this is what a generic three-circle Venn diagram looks like. Notice it overlaps everything slightly. They're harder to draw than you think they are, but you'll discover that very soon. Because you'll draw one and then you'll start trying to put numbers in, and there's like no space to put a number in at. How many different compartments are there inside a three-circle Venn diagram? 8. There's 8. I'm going to number them for you. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 different parts inside a three-circle Venn diagram. That's very important to know. So I'm going to write 8 parts. I don't really know what they're called. Regions. Whatever you want to call it. Okay. It says label the individual regions of the Venn diagram above. We did that. Use it to find the following. Okay. So this right here. What does this read? A intersect B. Now interpreting that in words we understand, how do we interpret that? It's in A and it's in B. It's in A and it's in B. Now I'm going to kind of show you, rather than, because these get hard, especially when you add 3 of them to it, it gets hard to just think it through. We could think this one through. It's in circle A, so we narrowed it down to these 4 numbers, 1, 2, 4, 5. And it's in circle B. So out of these 4 numbers, we're talking about 2, 5. Right? Okay. Sometimes that gets a little too hard to think. So I'm going to show you another way to think of this. So doing it in pieces, we have our intersection here, which means and. On the left side, it says A. So what I'm going to do is I'm going to write down all the elements that are in circle A. So circle A has the numbers 1, 2, 4, and 5 in it. On the right side, it says B. So I'm going to write down all the numbers that are in circle B. 2, 3, 5, 6. And then the and part is very strict. It has to be on the left side and the right side to count it. And the only things that are on both sides are the 2 and the 5. And so this whole thing is going to equal the set containing 2, 5. Okay. So it's just a methodical way to think it out if you're having trouble visualizing it. Part B says A union C. We can interpret A union C to be A or C or both. We could also interpret it to be A plus C. When doing Venn diagrams, I find it easier to think of plus. That means we want everything in A. So on the left side of this plus sign, I'm going to write down everything in A. 1, 2, 4, 5. Plus, on the right side, I'm going to write down every number in C. 4, 5, 6, 7. So when I put these together to write down my answer, plus is the very friendly one. That means we want to include everyone on the left of the plus, everyone on the right of the plus, but don't add anybody twice. And so I need to include 1, 2, 4, 5, 6, 7. Note my curly brackets because when you operate on 2 sets, you get a set as your answer. Okay, the next one says A complement. What does A complement mean? How do we interpret that in our head? Not in A. So what I do, and I'm doing like these on my paper, don't be too proud to actually cover it up with your thumb. So just take your thumb and totally cover up A. Go ahead. I'm watching. If your thumb's not big enough, use more than that. So when you totally cover up A, what numbers are left? Any others? Any others? What about the 3 and the 6? Did y'all say that? Oh, just kidding. Okay, so when you totally cover up A, the numbers remaining are 3, 6, 7, 8. Everything not in A. Okay. The next one, it says A complement intersect B. A complement intersect B. that we're starting to get a little more complicated, so your brain can start twisting. So I'm going to write this out. I'm going to actually write and on top because that's what intersection means. And then on the left side where it says a complement, I'm going to write down everything not in A, which we just did earlier. So 3, 6, 7, 8. That's everything not in A. On the right side of the and, I'm going to write down B, which means all the numbers that are in B. So 2, 3, 5, 6. The intersection, the and, means I can only count them if they're on the left side and the right side. So they both have a 3, they both have a 6, and that's it. So this is going to be, oops. This is going to be the set containing 3, 6. Okay, I'm gonna snip this real quick, maybe. Why is it not letting me? Okay, so I moved a copy of our Venn diagram down here so we can see it better. So the next one says B intersects C complement. B intersects C complement. So what that means is it's not in the intersection of B and C. So let's try to just, since it's only 2 sets, let's try to think this out. It's not in B and C. So which of these numbers are in circle B and in circle C? 5 and 6. 5 and 6. So basically it's not 5 and 6. So if it's not 5 and 6, then it's the sets containing everything else. So it's the set containing 1, 2, 3, 4, 7, 8. Okay. So it's not in B and C, so it's not 5, 6. We good on that one? All right, part F, we started with 3 circles. Now here's a time where I'd really say, just kind of write down each little piece as you go along. So it says A union B intersects C. So the parentheses are the left side, C is on the right side. My main operation here is and, so I'm going to write and. Since the right side is easier, C, that means I'm going to write down all the numbers that are in C. 4, 5, 6, 7. On the left side, it says A union B, which we can interpret as A or B or both. With Venn diagrams, I like to think A plus B. So I want everything in A plus I want everything in B without repeating. So everything in A, 1, 2, 4, 5, plus everything in B without repeating. I already have the 2 and the 5. I need to add the 3 and the 6. Y'all with me so far? And then this and is the very strict one. It means I'm only going to be able to count these if it's on the left side and the right side. So they both have a 4, they both have a 5, and they both have a 6. So this is going to equal the sets containing 4, 5, 6. Okay, part G right here. I'm going to give you a second. I want you to try G on your own real quick. All right, so let's see how you did. This is plus right there, union, the very friendly operation. On the left side, we have B. That means I'm going to write down every number in circle B. 2, 3, 5, 6. On the right side, it says A intersects C. That means it's in A and C. So if I look at circle A and circle C, there's 2 numbers that are in both A and C. Those numbers are 4 and 5. The plus means we want everything on the left plus everything on the right. So this is going to equal the set, and don't repeat anything. So this is going to equal the set containing 2, 3, 5, 6, 4. So if we read part H, it says, C complement intersect A, union B. Which even to me, I'm like, yeah, what does that even mean? So I got to break it down into little bitty parts. So the union, my main operation here, is going to be a plus. On the right side of the plus, I have B. So I'm going to write down all the numbers in circle B. 2, 3, 5, 6. On the left side, I have C complement intersect A. So I'm going to write down in words, what does that mean? C complement means not in C. Intersection means and. A just means it's in A. So it's not in circle C. So you can just cover up circle C with your hand. So it's not in there. And it is in A. So what's in A but not C? 1 and 2. And the plus sign's the friendly one. So we want to include everything on both sides without repeating. So I'm going to have 1, 2, 3, 5, 6. So example I, again, we have like B complement union A intersects C. Don't even know what that means myself. So we're going to break it in pieces here. The main operation is intersection, so that means and. On the right side of it, we have C. So I'm going to write down all the numbers in circle C. 4, 5, 6, 7. On the left side, we have B complement union A. So I'm going to write in words what that means. That means it's not in B. For union, we could say or, but with Venn diagrams, I like to say plus. It is in A. So this one gets tricky. That union, that friendly one, it's going to include everything on the left, which is not in B, plus it's going to include everything on the right, which is in A, even if they contradict. So I'm going to highlight here. So everything not in B, that would be 1, 4, 7, 8. That's everything not in B. Plus, I want to add with this everything that is in A. So I also want to include what? The 2 and the 5. It doesn't matter if those two sides contradict. I want to include both sides. So on the left side of here, I'm going to have 1, 2, 4, 5, 7, 8. Then the and means I only want to count stuff on the left side and the right side. So they both have a 4, they both have a 5, and they both have a 7. So this is going to equal the set containing 4, 5, 7. Says, example 2, are the following statements equal? Hint, use a Venn diagram. So I'm going to draw a Venn diagram, a 3-circle Venn diagram. Label them A, B, C. This is where you can test how good you can draw these. Then, how many parts or compartments are inside a 3-circle Venn diagram? 8. I'm going to number them. You don't have to number them the same way I do. This is just how I'm doing it. It's scratch work, so it doesn't matter. And then to see if these two statements are equal, I'm going to find which numbers are on the left side and which numbers are on the right side. So looking at this first one, that means plus right there. So everything in A, which is 1, 2, 4, 5, plus everything that's in B and C. So which of these numbers are in circle B and circle C? The 5 and 6. And so this first one equals the set containing 1, 2, 4, 5, 6. And I'm comparing it to this one to see if that one's equal to it. So looking at this one, my main sign is plus. On the right side, I have C, which is 4, 5, 6, 7. On the left side, I have A and B. Which numbers are in circles A and B? 2 and 5. So this one's going to equal the set 2, 5, 4, 6, 7. So are these two statements equal? Do they have the exact same numbers in them? No. This next one says A union B complement versus A complement union B complement. Are they equal? Look at a two-circle Venn diagram. Okay, it's a two-circle Venn diagram. We only have A and B, so I'm going to draw my A, draw my B. How many little parts or regions are inside a two-circle Venn diagram? 4. 1, 2, 3, 4. So the one on the left says A union B complement. If we interpreted that, using order of operations, you do the exponent part first. That means it's not in A or B. So where is it? Which number is it? 4. That's the only number that's not in A or B or both. Y'all with me? Okay. Looking at this one though, it's not in A plus it's not in B. So put a plus here. It's not in A. Which numbers are not in A? 3 and 4. Plus, which numbers are not in B? 1 and 4. Plus is the friendly, so we add them all together but don't add anything twice. So we get 3, 4, and 1. So are these two statements equal? No. Let me show you this first one a different way right here real quick. A union B complement. If I took everything in A, which is 1 and 2, plus everything in B, which is 2 and 3, and I'm going to be complementing that. Then I'm going to complement 1, 2, 3, which is 4. Okay? So you look at this and you think, oh, yeah, they're equal. Actually, what happens is something called De Morgan's Law. You don't really need to know this yet. De Morgan's Law says if you have a complement outside the parentheses, you can bring it down to every individual set inside, but it flips your sign. And so A union B complement would actually equal A complement intersect B complement. They equal each other. But we won't get there yet. So, it says Liberty Travel surveyed 125 potential customers. The following data was obtained. 68 wished to go to Hawaii, 53 wanted to go to Las Vegas, 47 Disney World, and then it talks about Hawaii and Vegas, Vegas and Disney World, all three places, yada, yada, yada. So I'm going to go ahead and draw a picture. How many sets do I have going on here? 3. So I'm going to draw a 3-circle Venn diagram. Okay, you want to slightly overlap each of them. I'm going to label one of them Hawaii, one of them Las Vegas, and one of them Disney World. Very important not to forget the rectangle. If you forget the rectangle part of your Venn diagram, then your universe goes off your page. Okay? You want it confined right there. How many different parts are there in my rectangle? 8. And what will those 8 parts add up to be? 125. So I'm going to go ahead over here and put 125. Now if I started at the top, when it says 68 want to go to Hawaii, look at my Hawaii circle. How many parts are in my Hawaii circle? 4. So I don't know how the number 68 is broken up in that. I can't just pop a 68 in there. It's all broken up. Those 4 parts will add up to 68. So this one I can kind of tell it's going to continue like that till we hit the bottom. So I'm just going to skim to the bottom and start there. 18 wish to travel to all 3 destinations. So they want to go to all three places, so they're going to be in all three circles. So drawing your 18 in right there, now you're kind of realizing, man, I'm not real good at these circles because I can barely fit my 18 in here, right? And then I check it off, so I know I did that one. Working my way up, it says 23 wish to travel to Hawaii and Disney World. I'm going to read this slow. 23 wish to travel to Hawaii. Stop. I've narrowed it down from 8 to 4. Okay. And Disney World. Out of these 4, which ones are also Disney World? These 2. So those 2 need to add up to 23. I already have 18, so that leaves 5. "26 wish to travel to Vegas and Disney World." Read it slowly. 26 wish to travel to Vegas. Stop. I've narrowed it down from 8 to 4. And Disney World. Out of these 4, which ones are Disney World also? These 2. So those 2 need to add up to be 26. I already have 18, so that leaves 8. 34 wish to travel to Hawaii and Vegas. So Hawaii, that narrows me down to these 4. Out of these 4, where it says and Vegas, that narrows me down to those 2. So I already have 18, that leaves 16. The next one up, 47 want to go to Disney World. So my entire Disney World circle, which has 4 parts in it, need to add up to be, I gotta do my 4 a different way. There you go, 4 parts in it, need to add up to be 47. So right now if I add 5 plus 18 plus 8, that adds up to be something else. So 47 minus 5 minus 18 minus 8 gives me 16. Who are those 16 people? They only want to go to Disney World, not the other 2 places. 53 people want to go to Vegas. That means this Las Vegas circle here with 4 parts, those 4 parts are going to add up to 53. So if I do 53 minus those other 3 numbers, that leaves me with 11 people who want to go to Vegas only. 68 wish to travel to Hawaii. So my Hawaii circle is going to add up to be 68. So I do 68 minus those other 3 numbers, and I get 29 want to go to only Hawaii. Is there going to be a number outside the circles but inside the rectangle? And if so, who would it be? Right, they don't want to go these 3 places. I mean, they obviously are wanting to go somewhere because they're at Liberty Travel, but not these 3 places, okay? So if I take 125 and I subtract all the numbers that are in these circles, that's going to leave me with 22 people who'd rather go somewhere else. Okay. All right, so then we answer our questions. How many of those surveyed did not wish to travel to any of these destinations? 22. How many wish to travel only to Hawaii? 29. How many wish to travel to Disney World and Las Vegas, but not Hawaii? So here they're in Disney World and Las Vegas, so they're in this little football shape, but not Hawaii, so just 8. How many want to go to Disney World or Las Vegas, which in mathematics means or both, but not Hawaii? So they want to go to Disney World, which are these 4 circles, or these 4 parts, or Las Vegas, which are these 4. So right now we have these 8. They want to go to Disney World or Vegas or both, but not Hawaii. So it's these 3. 16, 8, and 11. Thank you. Okay, because that or means one or the other or both. So that only narrowed it down to those 2 circles there. How many wish to travel to exactly one of these destinations? So they either wanted to go to Hawaii only, or Vegas only, or Disney World only. Thank you, 56. And then how many wish to travel to exactly two of these destinations? So that'd be those people, or those people. Awesome. 250 college students were asked what they did last night. Completely fill in the Venn diagram below, given the following information. So when I completely fill it in, how many numbers will I have in there? Right, I'll have 250 people, but how many numbers will be inside my Venn diagram? 8. I have 8 places to fill in. So the first one says 169 watched TV. That means all 4 of these spots inside the TV circle will add up to be 169. I can't do it yet, so I'm skipping it. And I'm going to the next one. That says 16 went out to eat only. Can I do that one? Yeah. So I go to the 8 out circle and they only ate out. So they go right there and I'm crossing it off. 46 went out to eat, so stop a second, just pause. We've narrowed it down already from 8 spots to they went out to eat, so these 4. And they watched TV, so we've narrowed it down now from these 4 to these 2. But they did not study, so they're right out here. $132 did not study. This is where you take your thumb or your hand and you completely cover up the study circle, and there should be 4 numbers outside of that that'll add up to be 132. We can't do that yet because we only know 2 of those numbers, so we're going to skip it. 18 went right to bed without doing any of these. Can we do that one? Mm-hmm. And now, in fact, we can go back. So if we go back to 132 did not study, cover up the study circle. The other 4 spots need to add up to be 132. So we can do 132 minus those numbers. And we get 52 people in that missing spot there. Who are those 52 people? They only watched TV. They did not eat out or study. $31 did all 3 things. Can we do that one? Mm-hmm. $141 did at least 2 of these things. So at least 2 means they either did exactly 2, which would have been these people, or they did all 3, which would have been those. So we can't do that one yet, so I'm going to skip it. I'm going to go back to the top now. So I only went through 1 time, and I filled out a lot of numbers. I guarantee you, at most, you'll have to go through 3 times, and they'll all be filled out. This will only take 2. So back to the top, 169 watched TV. So my TV circle needs to add up to be 169. So if I do 169 minus all those numbers in there so far, that leaves me with 40 for right there. And then down to the bottom one again, 141 did at least 2 of these things. So that's all the yellow spots happening there. So I can do 141 minus all those numbers, people who did exactly 2 or 3. And that would leave me with 24 right there. So I answered all my bullets, but I have one group of people missing. Who are those people? People who only studied. They did not watch TV or eat out. How do I find out how many there are? 250 minus all the numbers in all the other numbers, basically. And I'll get 23 people who only studied. Okay. At an Aggie football game, At an Aggie football game last year, 410 fans were asked what they bought from a concession stand during the game. Fill in the Venn diagram completely. So far we know all 8 of these are going to add up to be 410. The first one says 358 bought a drink. Can we do that one yet? No. Too many. There's 4 spots. 142 bought a drink. So we've narrowed it down to these 4. And a hot dog. So out of these 4, hot dog is also these 2. Can't do that one yet. 23 bought only nachos. That one we can do. So sometimes when I'm doing these, if I'm going to go back later and study them, I might make a note out here like this was the first one I was able to do, just so I know later. I'm talking hypothetically as if I were you, okay? 92 bought nachos and a drink. So if they bought nachos, we've narrowed it down to these 4, and a drink narrows it down to these 2. Can't do it yet. 44 bought nachos. I'm going to pause right there. So we're at these 4. Or a hot dog. So that means or both. So nachos or a hot dog or both. So we're talking about all 6 of these spots right there. But not a drink. So we're just talking about these 3 on the outside. Can't do it. 40 bought all 3 things. That one I can do. And 161 bought exactly 2 of these things. So that would be these 3 spots. So can't do that yet. So my first time through on this one, couldn't do very much. That's okay. Second time through. 358 bought a drink. So my entire drink circle will add up to 358. Could I do it yet? No. 142 bought a drink, so I've narrowed it down to these 4, and a hot dog, so I've narrowed it down to these 2. I already have 40 people in there, and it says 142 need to be in there. So I'm missing 102. Who are those 102 people? But not nachos. But not nachos. Bought a drink and a hot dog, but not nachos. 92 bought nachos and a drink. So if they bought nachos, I've narrowed it down to these 4. And a drink, I've narrowed it down to these 2. So, question, those 40 right there, did those 40 buy nachos and a drink? Yeah. They bought other things too, but they did buy nachos and a drink. So when I say 92 bought nachos and a drink, I already have 40 in there. So that leaves 52 to go out here. These people bought nachos and a drink, but not a hot dog. 44 bought nachos or a hot dog, but not a drink. So nachos or a hot dog means nachos plus hot dog. So all 6 of these spots, but not a drink. So cover up the drink circle. So it's just these 3 spots. Can't do it yet. 161 bought exactly 2 of these things. So we already have the 52 and the 102. We can figure out the other one. 161 minus 52. Oops. I don't know what's going on there. Minus 102. And that leaves us with 7 right there. So that was my second time through. My third time through should do it. 358 bought a drink. That drink circle needs to add to 358. Can I do that one now? 358 minus all those numbers would give you 164. 164 people who did what? Only bought a drink, not nachos or hot dog. Only one other bullet says 44 bought nachos or a hot dog, but not a drink. So nachos or a hot dog, so we're talking about all 6 of these, but not a drink. So just these 3. So those 3 need to add up to be 44. And so I could do 44 minus 7 minus 23, and I get 14. Who am I missing out here? Who are these people? Not that they didn't buy anything. They didn't buy these 3 things. They could have gone to the concession stand and bought other stuff, but they did not buy a drink, nachos, or hot dog. And so I take 410 minus all those numbers, and I get 8 people who either didn't buy these things or bought something else or whatever. So questions. How many bought a drink or a hot dog? What does that mean? Drink or a hot dog? Or both. Either one or both. So when it says drink or hot dog, I'm going to highlight this. Maybe. They bought a drink or a hot dog or both. So I need to add up all those numbers right there. And I get 388. How many did not buy nachos? Just take your hand and completely cover up the nacho circle. How many numbers do you have to add up? 4. So add 164 plus 102 plus 14 plus 8, and you'll get 288. So we're going to be coming back to example 4, but let's do example 5 a second. So this one is hard. The other one's like they either bought a drink or they didn't, right? So they're in the drink circle or they're not in the drink circle. Okay? This one messes with you sort of because it's talking about girls, and we have a circle for girls, but then it's talking about boys. And you're like, well, where's the circle for boys? Okay? If they're a girl, they're going to be in the girl circle. These 4 spots are girls. Where are the boys? Everyone who's not a girl. Right? So boys, 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 boys. If they failed, they're in the failed circle, those 4 spots. If they passed, where are they? Outside the failed circle. Okay? So these words tend to kind of mess with you a little bit. A survey was conducted among 75 teenagers, so I know this whole thing has a 75, who recently took their driver's test to get their driver's license. Completely fill in the Venn diagram below based on the following information. Note 2 numbers have been filled in for us. So we have a 5 in there and an 8 in there. Let's talk about that 5 real quick. Who are those 5 people specifically? They are girls who are 18 or older and passed their driver's test. Okay. Who are these 8 people? Girls who passed, who are under 18. Okay. It says 27 girls took the test, so the whole girl circle will add to 27. Can't do that yet. And read these very slowly. 13 students under 18 years. Stop right there. We've already narrowed it down from all 8 of these to the fact that they're under 18 years means it's just these 4 spots right here because they're not in that circle. Okay? They're under 18, so it's just these 4 spots. And then it says they failed. So out of these 4 spots, how many spots failed? Those 2. So those 2 will add up to be 13. Can't do it yet. 10 boys. So if you read 10 boys failed their test, then you'll be going, huh? So you read 10 boys, and you stop, and you figure out where you are. If we're talking boys, then they're not in the girls' circle. So we're talking these outside 4. So 10 boys, and then it says they failed. So from these outside 4, the ones who failed would be these 2. And then it says, oh, that's all it says. So these 2 will add up to 10. 10 girls, stop right there. They're girls, so they're in this circle, who are 18 or older. So from these 4 things, the 18 or older group is these 2. And then it says they failed. So they're right there. So these are 10 girls, 18 or older, who failed. 30 teenagers. So that's boys or girls. That's anybody. Under 18 years old. So they're not in this circle anymore. They're under 18. So we're talking about these 4 spots right there. These 4 spots. Under 18. And it says they passed. So out of these 4 spots, the ones that passed would be right here. I already have 8, and it tells me there's 30 total. So how many are out here? 22. Okay, so stop a second. Who are those 22 people specifically? they passed, they're boys, and they're under 18. So there were 22 boys under the age of 18 who passed. Okay. All right. 16 boys, so stop right there. They're not girls, so cover that up. So they're boys, one of these four, who were 18 or older. So out of these four, 18 or older would be these two. And it says they passed. So out of these two, they'd be right there. Back to the top. 27 girls took the test. Can we do that one now? Yes, so the girls circle needs to add to 27. If we do 27 minus 8 minus 5 minus 10, we get 4 right there. 13 students under 18 years old. So pause right there. If they're under 18, they're not in this circle. They're outside the circle. So if they're under 18, they're these spots right here. And then it says they failed. So out of these 4 spots right here, they failed. That's these 2. I already have 4 in there. So how many does that leave right here? Y'all with me? Okay, right here. 13 students under 18 years old. So under 18, I'm going to highlight it. Under 18 would be these 4 spots. And then it says they failed. So if they failed, we're talking about these 2 spots. I already have 4 there, so that leaves 9. And who are those 9 people? Boys under 18 who failed. 10 boys, so they're not in the girls' circle, failed. So they're right here, these 2 spots. So those 2 spots add up to 10. Right now I have 9. That leaves 1. So I had to think a little bit on that one. Questions on that one? I know your brain's burning out, but I'm going to do one more with you here. We got 7 minutes. Country western songs seem to emphasize 3 basic themes: love, prison, and trucks. A survey of a local country western station produced the following data. 12 songs were about truck drivers and love, and then we got prison and all this. So we have truck drivers, love, and prison. So I'm going to make a 3-circle Venn diagram here. And I'm going to label one of them love, one of them prison, and one of them truckers. And so it said, it doesn't tell us how many there were. It says 12 songs were about a truck driver who was in love while in prison. Don't read it all like that. Read it slowly. 12 songs were about a truck driver. So we've narrowed it down to these 4. Who was in love? So from these 4, we've narrowed it down to these 2 while in prison. So out of these 2, we've narrowed it down to this 1. Oh, but I need to do 12. Sorry. "13 songs were about a prisoner in love," but I'm going to read it slowly. 13 songs were about a prisoner. So I've already narrowed it down to these 4. Out of these 4, we're looking for people who are in love. So now I've narrowed it down to these 2. I already have 12 in there, so that leaves 1. "28 songs were about people in love." Okay, so they could be in prison or not, truck drivers or not, they're just people in love. So the love circle is going to add up to 28. Can't do that yet. 30 songs were not about prisoners. So if you take your hand and you cover up the prison circle, then the other 4 spots would add up to 30. Can't do it yet. 18 songs were about a truck driver, so stop. We've narrowed it down to these 4. In love. So out of these 4, we've narrowed it down to these 2. We already have 12, So that leaves 6. Three were about a truck driver, so we've narrowed it down to these 4. In prison, so we've narrowed it down to these 2. But was not in love, so we narrowed it down to that 1. "16 were about truck drivers, so we narrowed it down to these 4. Who were not in prison. So out of these 4, we've narrowed it down to these 2. We already have 6. That leaves us 10. 17 were about people in prison or in love. That means or both. So they were in prison or love or both. So that's talking about all 6 of these. But they did not drive trucks. So that's just talking about these 3. Can't do it. Going back to the top. 28 songs were about people in love. Can we do that one now? Yeah. So the love circle currently has 19 in there, so that leaves 9 right there. 30 songs were not about prisoners. So take your hand and cover up the prisoner circle. The other 4 spots should add up to 30. Right now they add up to 25, so that means 5 people are out here. 17 were about people in prison or love, so all these both these circles, but did not drive trucks. So these 3 out here. So we already have 13. That leaves 4. So then we can answer these questions real quick. How many songs were surveyed? What would you do for that? Add up all the numbers. If you add up all the numbers, you'd get 53. How many songs were about truck drivers in prison? So they're truck drivers, so they're in this circle, and they're in prison. So those 2. So how many? 15. How many songs were about prisoners, so they're in the prison circle, who were not in love and did not drive a truck?